Hey guys, so today what we're going to do is we're going to just build on our understanding of ions, and we're going to talk today about, not about ionic compounds anymore or how to form neutral compounds. We kind of did that last time. Instead, what we're going to focus on is we're going to focus on actually converting from, let's say you're given a formula or you're given a name, how do you kind of find the other one? So let's go ahead and start with, let's say that you're trying to find, you've been given the name barium nitrite and you're trying to figure out the formula. Okay, here we go. First thing you're going to need to know is you're going to need to know what the charge of the metal is. In this case, that's the first word, and you're going to need to know what the charge of the nonmetal is. That's the second word. Now, how you figure this out is, well, you find barium on the periodic table, and then you kind of figure out which column is it in. Barium's in that second column, so it would be a 2 plus. Nitrogen, or nitride in this case, it's actually nitrogen. We'll talk about how to form this nitride ending, is in the 15th column. So everything in the 15th column has a -3 charge. So boom, you found the charge of the metal, you found the charge of the nonmetal. Now, the next part, step 3, is the trickiest. After you found the charge of the metal, after you found the charge of the nonmetal, the hardest part is kind of figuring out the least common denominator between the two charges. So in this case, we have 2 plus and we have 3 minus, right? So we're going to need the 3 minus to get to 6, and we're going to need the 2 plus to also get to 6, so that we can have 6 plus and 6 minus on either side. So we need 6 plus from our bariums, and we need 6 minus from our nitrides. In order to get that, as you see here, I've kind of shown you the answer, you're going to need 2 nitrogens, because 2 nitrogens each with 3, 2, or 3 plus 3 gives you 6, and then 3 bariums each have a charge of +2, so +2 plus +2 plus +2 gives you 6, so 6 and 6 kind of cancels out. And then when you're done with that, you just write down how many ions are needed to equal the least common denominator. And once you have that, you're good to go from there. Okay, so here's just kind of another way of showing that. Here I have barium, here's a +2, here's nitrogen is a -3, and you'll see right now, they're not balanced because I got 2 plus and 3 minus. That's not equal, right? So if this was the correct answer, I would write just BAN. I wouldn't write the 1 here and I wouldn't write the 1 here. I'm just kind of showing you what the numbers are. Now what I'm going to do is add another barium just to kind of, again, try to balance them out. This is a good way to just kind of guess and check and figure out how many of each do I need, right? If I have 2 bariums and 1 nitrogen, you'll notice it's +4 versus -3. Again, that's not equal. So we're just going to kind of keep going. Now I'm going to add another nitrogen, and that's going to give me +4 and -6 if I have 2 of each. This would be how you write down Ba2, N2. Again, this isn't the correct answer because my numbers are not even here. So I'm going to need to add a third barium. And then once I do that, I've got 6 on one side and 6 on the other side. These 3 2 pluses add up to 6, and these 2 3 minuses also add up to 6. So that gets me nice and balanced out. So my final answer here, Ba3 and 2. And we're feeling good to go. So yeah, you can go ahead and try these out. We're actually going to skip right over this. We'll work on this in class. What I wanted to talk about now is, let's say I gave you a formula like NaCl. How do you figure out what the name is, right? Okay, so it turns out that the rules are very simple. You just name the metal, whatever the metal's name is. So Na is sodium, so you just name it sodium. Boom, there we go. Halfway done right away. Pretty awesome. The second step is a little bit more complicated. So Cl is called chlorine, and you would know that by looking on the periodic table, in the same way that you know that Na is sodium, again, by looking on the periodic table. But then you're going to take whatever the ending is, so in this case, chlorine ends in INE, and you're going to switch that out to IDE. So instead of being sodium chlorine, it's sodium chloride. You do this only for the nonmetal, only for the red part here, only for the second element, and the nonmetal is always going to be the second element. So that's kind of nice. Yeah, and then you switch from "ein" to "ide" is kind of the idea there. Just to reiterate here, metal always comes first. So I would pause the video right now, and I have these 3 steps written down. Name the metal, the metal's name, and then name the anion, but change the ending so it's an IDE ending. Go ahead and write that down, please. Great, let's move forward here. Okay, so there's a couple non-metals, there's 5 of them, that don't really end in INE. So their ending, how you change that ending to IDE is a little bit trickier. So for example, nitrogen is not nitrogide, it's just nitride, right? And that stands for N3 minus. So this is the ion form of nitrogen. Oxygen is not oxygide, it's just oxide, which you've probably heard of if you've heard of things like carbon dioxide or carbon monoxide. I don't know, something like that. Phosphorus is not phosphoruside, it's just phosphide. So you actually get rid of the OR and everything kind of from here on out. Sulfur is you just get rid of the UR, so it's sulfide. Selenium is you get rid of the UM, so it's selenide. So yeah, just so you know, those are kind of 5 or so trickier ones. Hopefully it kind of makes sense and it sounds proper, kind of where we cut off the letter and add the IDE to. So yeah, let's keep going here. This is just a meme about ions. I thought it was funny. Okay, so the best way to learn here is to practice a lot. So let's go ahead and take a moment to do that. We'll go through a couple problems together. Mg stands for magnesium. S stands for sulfur. So our name would be something like magnesium, and then S would be sulfur. We change that to an IDE ending, so it's magnesium sulfide. For the next one, Al is aluminum. O is oxygen, so our answer should be just aluminum, just regularly, and then oxygen turns into oxide. Notice the IDE ending there. Ra, you might have to look for this one. It's a little bit trickier to find. And Cl2 for the next one. Again, notice how in question number 2, we didn't do anything with these additions of the numbers. The numbers don't mean anything in terms of how the name is written. Remember, that's all about charges. So for example, in number 2, Al has a 3 plus charge. And O has a 2 minus charge. That's why I have 3 O's and 2 ALs, so that they both equal positive and negative 6. With RaCl2, Ra stands for radium, and Cl stands for chlorine, but it wouldn't just be radium chlorine, it'd be radium chloride. Hopefully that helps. And then for these last ones here, notice that I've changed all the endings already to nitride. First thing you're going to want to do for this, and it's probably the hardest part, is find them on the periodic table and figure out what charges they are. Go ahead and pause the video right now and try and do that on your own. Great, here we go. Calcium has a charge of 2 plus, and oxygen has a charge of 2 minus. So we're only going to need one of each of these because they balance out with just 1 and 1, right? 2 plus 2 minus, that balances out. So it's just CaO, which is kind of nice. Potassium has a positive charge, just a positive 1 charge, and sulfur has a minus 2 charge, or sulfide has a minus 2 charge. What that means is we're going to need 2 of these potassiums. We're going to need 2 of these 1 plus charges so that we get 2 plus and 2 minus, so it's K2S. Lithium also has a plus 1 charge for the next one, and nitride has a 3 minus charge. What this means is we're going to need 3 of these lithiums over here. So it's going to be Li3N. Notice that the subscript comes after the letters of whichever element. So for example, this 2 here means I have 2 aluminums, and this 3 means I have 3 oxygens. This 3 here means I have 3 lithiums, and this N without a number just means I have 1 nitrogen. Great. Hopefully that helps with our understanding of, stuff. Have a great rest of your day, guys. We'll see you next time.